Yeah, good evening, students. For the students who are joining, we'll be starting the session in few minutes. So let me just play a small video. So before we have a good, fruitful session regarding chemical engineering.
Hello, I'm Dr. J. Narayanan, Professor and Chairperson of the Department of Chemical Engineering and Material Science. I joined Amrita in the year 1999 and I have been working in the Chemical Engineering Department since the year 2007. My area of specialization is Polymer Science and Engineering. We have a team of excellent faculty in our department. 90% of our faculty have PhD from eminent institutions and 50% of them have industry experience too. We have a strong focus on undergraduate and postgraduate education with socially conscious research. In the year 2013, we received a major funding from MHRD to set up the Center of Excellence in Advanced Materials and Green Technologies. As part of this particular center, we have a lot of translational research happening, and this research is focused towards the needs of the society.
Yeah, good evening, students. Let's just wait for a few more minutes. We'll start by 6:05. More people are joining in. Let's wait for 2 more minutes before we start.
As per far as my life in Amrita is concerned, well, whatever I am today, it's because of Amrita. Be it on my academic front, be it on my co-curricular front, like talking about music and other stuff. 4 years of my life, having been an NRA, I grew up all my life in the Middle East, and then came down to India for my 4 years of bachelor's degree. My first experience of Indian education system in India. It was a really fantastic experience.
My time in Amrita, I would say it was like a roller coaster ride. It had lots of ups and downs, but at the same time, it taught me a lot. Not only on how to navigate through my career, but just how to navigate through life in general.
I had the best 4 years of my life in there. The campus, the faculty, the friends, the knowledge, the experience is just amazing. And being a chemical engineer is fun. I know I had interacted with a few juniors, and especially when you start out, you're not so sure about what it is and if it's the right thing, because it's not a very common stream of engineering, and a lot of people are usually skeptical about it. But I think it was one of the best choices that I ever made.
I felt that the program was full of exciting and challenging courses that I really enjoyed taking. The professors in particular really helped us understand the fundamentals by facilitating a lot of discussion and questioning. And since most of them also have a significant amount of industrial experience, they also helped us put the concepts that we were learning in the perspective of industrial practice. And this for me was a distinguishing feature of the learning that happened at Amrita and in the department. So along with this, on the co-curricular front, there were multiple opportunities for us to take up projects, work on research studies along with professors and graduate students. And most of this was enabled by the facilities and projects that were run by the Center of Excellence in Advanced Materials and Green Technologies here at the department. And along with all these opportunities, there are also some very innovative hands-on and experiential learning opportunities in the Living Labs program. So all these aspects, along with the great people that we have over there, went along to put together a very memorable and enriching learning journey for me. I'm incredibly grateful for that.
Definitely, Amrita.
Yeah, a warm welcome to all the attendees who are eagerly waiting to understand what we are going to discuss today. And the topic of today's session is all about chemical engineering. I know it's completely normal to feel afraid or uncertain about pursuing a new career path, especially one as challenging as chemical engineering. So, all of you who are present today, one thing you need to understand is, before we dwell into this session and get more insights from our faculty, and I'll keep introducing them, I don't take much of their time dwelling upon the introduction. One thing you need to understand: when we are going to purchase a small dress, what we will do, the process involved is going from shop to shop, understanding the material, understanding the brand, understanding the size, is it fits you or not. We will explore 2 3 shops before finalizing on a particular dress which you are going to wear for 1 year. An engineering degree is for 4 years. So how much research or exploration is required when you are finalizing about a branch or about a program that you are going to spend 4 years of your valuable time studying, getting grades, and graduating from it and getting a placement. So it's up to you to explore and get a more in-depth understanding about each and every engineering program that is available for you, especially in Amrita. Since we are one of the best universities in the country, we should know what Amrita University has to offer for chemical engineers. One way to address your concern is to gather more information. Now, of course, all of you agree with me on that. And to understand what exactly it is there in this branch, what kind of opportunities that are there in this branch, what kind of scope is there in this chemical engineering program. So all these things we will be discussing in brief. Today, we have with us esteemed faculty from our university. First, let me take a small note to introduce both of them before we go into the session. We have our first panelist, Dr. Meera Balachandran, ma'am. Good evening, ma'am. So she is a professor from chemical engineering. A warm good evening and welcome to this session. She is a PhD from Amrita University and MTech from Cochin University. And her research areas include high performance polymers, composites of space, nuclear defense and structural applications, sustainable chemicals and polymers from biomass. Okay, and there are other research areas which are very much prominent in demand in this in the specific time as we live in today. And she authored 3 book chapters, serves as a reviewer for several international journals. She is a life member of Indian Society for Advancement of Materials and Process Engineering. A warm welcome to you, ma'am. Once again, thank you for accepting our invite and to be part of this session. And our second panelist is Dr. Uday Bhaskar Reddy, sir. He's a professor, chemical engineering, PhD from Florida Institute of Technology, USA. He has published more than 25 articles in reputed journals and completed projects worth 7 crores. He has received Unlock Ideas Campaign Award from Lam Research USA for 2 consecutive years, 2019 and 20, for the design, high heat removal systems for semiconductor wafer fabrication systems. A warm welcome to you, sir. Thank you for accepting our invite and to be part of this session.
Thank you, Sudhir. Good evening to all.
Yes, sir. So, without any further ado, I just want to dwell into the question since our students are eagerly waiting to know. My first question is to Meera, ma'am. So, ma'am, I'll ask a question in general, chemical engineering in general, which as a parent, as a student, I want to know. It's a very basic idea or a fear or a dilemma every student will have. Is chemical engineering relevant to our lives? If it is relevant, how relevant it is? And are there any job opportunities for chemical engineers? Can you just explain it in briefly, ma'am?
So first of all, a very warm welcome to all engineering enthusiasts. So let me start off with telling you what is chemical engineering. In simple words, chemical engineering is the branch of engineering concerned with the design and operation of industrial chemical plants. In broader terms, chemical engineering, also called process engineering, involves the design, development, and operations to process lower value raw materials or resources into higher value products in a safe, cost effective, and environmentally responsible way. It is the broadest branch of engineering that bridges the gap between science and manufacturing. If you look around, almost everything that you see is somehow connected to chemical engineering and is a product of chemical engineering, from face cream to fuels, textiles, medicines, FMCG products, materials used in automobiles and even rockets, semiconductors used in our electronic devices. The list is endless. Modern society relies on the work of chemical and process engineers. They help manage resources, protect environment, and control health and safety procedures while developing the processes that make these products. Now, as far as job opportunities for chemical engineers are concerned, chemical engineers work in diverse industries with the major employment sectors being petroleum and petrochemicals, industrial chemicals, pharmaceuticals, food and agriculture, consumer goods, electronics, health and hygiene products, energy and environmental management in various job roles like in production, process design, construction, plant improvement, debottlenecking, research, technical development, product development. It's a big list. But the services of chemical engineers are not just limited to chemical and allied industries. We are employed in diverse fields like material development, design and construction of process plants, equipment manufacture, information technology, data analytics, consultancy, etc. I hope I've given a broad overview of what is chemical engineering and where the opportunities are.
Yes, ma'am. I think you have answered it and crisply kept in a short note that today chemical engineers are everywhere. It's us to notice what are the opportunities that are there, because as you explained, they are there in every domain. They are there in each and every field, and people should understand today chemical engineers plays a vital role actually how we live in this current 21st century based on our habits or based on our spending or all other things. You can see chemical engineers involved in all these domains ma'am specified. Sir Uday sir, my next question is to you. Actually, if you consider the current global scenario with the so-called evolution of this IT technology that is happening. So, what kind of opportunities you see a chemical engineers to have, and also are there any current trends that are happening in this chemical engineering sector?
Sure. Good evening, all the attendees. I will take up the first question, that is, what is the current global scenario? Maybe no, there is a no, lot of pickup in IT and other things, and how it helps the chemical industries. First of all, if you look at not the if you look at the needs of the humans and the society in large, we generally say in Hindi, right? Roti, kapada, makan. So we generally say it's food, cloth, and shelter, right? So but I will also add, apart from shelter, so the most thing that we also require is the energy, maybe for transportation, whatever you call it. So I will call it as food, cloth, shelter, and energy. So all these four are important. So, and that is where even the wars are happening and the things, especially for this, right? So whenever you say food, food doesn't also doesn't mean only the solid food that we take. It is also important, which is important. The other things that are important for us is clean air and water as well. So if you look at, these are the global challenges, that the entire world is facing. Having clean air, clean energy, and clean water, and of course, the healthy food that we take. Now, given the computer science that has been picked up so much, and how it will help the chemical industries, the if you especially if you look at the specialized branches of computer science and engineering, something like data analytics or the artificial intelligence. So artificial intelligence, please note, artificial intelligence can only help in finding the best path that we might have to take, especially given in a chemical process industries, right? But the AI cannot replace the chemical industry as such. Suppose, whenever, so as Meera madam explained, the chemical industries will convert raw material into product. So AI cannot convert a chemical raw material into product, but it will help. The AI technologies or computer technologies will help us in identifying what is the optimal path or what is the best path to convert the raw materials into products. And coming to the second questions, what are the current trends in chemical engineering? Obviously, one is the digitization of chemical process data, where your AI and data analytics will come into play. The foremost important of the current trend in chemical engineering, the sustainable chemical process, wherein how do you produce a product? How do you produce a product? So for example, the cloth that we wear, so that is the primary component of that is basically nylon 6X, which is coming from the adipic acid, which is coming from fossil fuels. So can we produce this chemical in a sustainable way, maybe from a green raw material or a renewable resource? The other trends are the waste management and circular economy, plant safety, and green chemistry.
Sure, sir. I think you have rightly said, even with the automation or with the trends that are happening in AI, so they can optimize the process, but the process that need to be executed or monitored is by humans, that are chemical engineers. That rightly said, which is all the students who are here need to understand. So for chemical engineers are very much in need, even we see there is an automation or the advancements of AI that we are having today. But when you discussed about the process, so whenever we discuss about chemical process, Mira ma'am, this question is for you. So we discussed a chemical process means automatically it does some harm to the environment. Okay, so how can actually chemical engineers contribute to the development of sustainable process actually that have a minimal impact on our environment or the resources that we are using today? Or are there any successful implementation of this in our industries currently? Are there any principles like that? Can you just explain now?
Sure. I think this is the apt question for today's world. Okay. So let me tell that chemical engineers are in the forefront of developing sustainable process design that minimize resource consumption of resources and also minimize waste generation. They are also involved in developing new materials from sustainable sources, generating clean energy, capturing emission like CO2 capture, carbon dioxide capture, developing large-scale energy storage devices and systems, removing contaminants from air, water, etc. So, in a nutshell, chemical engineers address some of today's most pressing environmental problems. Some examples of sustainable processes that our team at Amrita, our team of chemical engineers at Amrita are working on include hydrogen production from biomass, which Dr. Uday is working on. Another project that we are working on along with our BTech students is development of or manufacture or synthesis of polyethylene furanate, which is a polymer used for replacing PET, that is used in packaging and contribute a lot to environmental pollution. We are trying to make that from agro waste. Then we also work on recycling and upscaling of end-of-life polymer components. Our team is involved in developing AI integrated sensors for monitoring soil micronutrients. Then some of us are working on bioremediation for industrial waste treatment. So the areas are huge and the opportunities are really diverse and challenging.
Yes, ma'am, that's rightly said. How Amrita is adopting a sustainable chemical process, and we are the forefront at the forefront as a university, leading university. We should set the example. That's rightly said. We are adapting these.
And as far as what all have gone for commercialization on an industrial scale, if you see all around the world, green chemistry principles are being used. For example, production of biodiesel from waste and biomass to replace conventional fuels. Then to reduce the emissions of volatile organic compounds, usage of subcritical fluids like carbon dioxide, etc., have been taken up and very successful in industrial large-scale industries.
Yes, ma'am. So I think every industry is now actually looking for this sustainable process because otherwise it's hard to survive, and decreasing the environmental impact is the main primary goal of an industry. Actually, before setting up an industry, first priority of an industry is how much we are affecting the environment. So I think this is what every industry is looking forward to do. That's rightly said. Sir, Uday sir, as Meera ma'am said, since you are involved in executing a sustainable process, actually, can you let us know the challenges that our chemical engineers face in adapting to a cleaner technology, cleaner energy alternatives?
Yeah. See, one of the critical item where you call a chemical process to be sustainable is the use of clean energy. So clean energy may be coming from solar, wind, or biomass. So of course, solar and wind are the cleanest energy, whereas biomass, though it is cleaner, but it is renewable. So it can be used vice versa. If you look at the no, suppose if as a chemical industry, if we want to adapt this no, to clean energy so that the process can be sustainable, the example that I would like to take up here is the steel industry. So if you look at the I think if I remember correctly, I think India is the number one steel producer in the in the entire world. Probably if this maybe one, it is either first or second. And suppose if I need to, and steel industry uses a lot of coke, so to convert the iron ore into steel, what we get, right, to get Fe metallic iron, and it uses coke, so there is a lot of CO2 that is getting emitted from the from the process. So how do we reduce it? So the only alternative to coke is using gas phase hydrogen. So if you are able to produce this gas phase hydrogen from the clean energy, that is either from solar or wind, means please note, solar and wind will give you only electricity. So therefore we have to actually convert that into hydrogen, so through water electrolysis. So now if you look at, if I can give some numbers here, if I need to produce 1 ton of steel, it approximately requires 50 kilograms of hydrogen. So that means this will translate to 2,500 electricity units approximately. So that means if I need to change my entire process to the cleaner energy, either based on solar and wind, if you look at the area that is required, so it approximately requires 2 acres of land if I put a windmill, or it approximately requires 1.5 acres of land if I put a solar panel. So, so these are the kind of challenges. So space may be a constraint. So we have to be little careful in adapting to the overall cleaner or sustainable, you know, chemical process.
Yes, sir, that's rightly said. I know the challenges will be there whenever we are adapting a process that should have a less impact on environment. There will be challenges for sure, but we are trying to come up with new methodologies to reduce that impact. That's good to hear. But my next question is about the current hype word, ma'am, Mira ma'am. See, everybody is talking about AI, machine learning, data analytics. So everybody is behind these things. This is going to change the world. This is going to change the way we work, change the way we live. So all these things are happening around us. And how exactly the role of data analytics and AI is happening in chemical engineering? This is the main thing which I want to know also with, along with the students. How are data analytics, machine learning, and artificial intelligence being integrated into chemical engineering? So can you please let us know?
Yes. Okay. Chemical engineering is actually a data-rich branch of engineering. We deal with data all the time. Data from the plant, data from experiments, etc. So data analytics, machine learning, and artificial intelligence is being increasingly applied in chemical engineering across the various subfields of chemical engineering, like molecular simulations, material design, design and optimization of chemical reactors and other process equipment, developing empirical models for production, then monitoring and controlling of chemical process plants. Even in financial analysis and valuation of chemical projects, data analytics and AI are being increasingly used. Actually, we are now equipped with very powerful tools in data science and machine learning, and we have the capability, or we are developing the capability to tackle complex challenges, and the opportunities are endless. So, to tap into these opportunities at Amrita, one of the specializations we offer for chemical engineering students, beta chemical engineering, is process data analytics and AI. And I think we are the only university in India offering this specialization for chemical engineering graduates.
That's very good to hear, ma'am. Actually, when we talk about all these things as a chemical engineer, how relevant the department is, because from outer work, perspective, what I can tell is in chemical engineering and chemical processes, I can see a lot of data involved, how to analyze this and how to come up with an actual conclusion based on the data that we arrived from these experiments and all is plays a vital role, and that is happening, I think, in our university with the specialization. That's good to hear. But Uday sir, I just want to ask, do they require actually any skills to harness the potential of these technologies?
Yeah, definitely. Of course, no, it may not be required at the school level. I guess that all the attendees are from the high school students, +1 or +2. Uh, what they are learn what they have learned in +1 is probably the probability and statistics, little bit of statistics and probability. So that is the core of the process optimization, and the artificial intelligence. So statistical probability is the will be the decision, means that is the logical thinking that we apply. And apart from the statistical probability and statistics, we also require logical thinking. Where do apply these statistical laws and probabilistic laws? Where do we apply? That is the logical thinking that we need to gain during the course of the study of 4 years. And definitely, since we handle large data, whenever you talk about process data analytics or artificial intelligence for process optimization, we definitely require a program. It cannot be done by hand because we deal with a lot of data points. So it definitely requires a programming language, be it Python. To some extent, Microsoft Excel can also be used, but definitely either Python or MATLAB programming will be definitely useful. But those will be taught when during the course of that study at Amrita.
I would also like to add that, we offer, for a student who is interested in process data analytics and AI specialization, apart from the first year, computational course that they learn, we have computational methods in chemical engineering and mathematics lab where they will learn MATLAB. And they get to learn 6 to 7 different subjects pertaining to this specialization. And all our courses, we just don't teach them theory. They are all integrated with lab. They get hands-on training in whatever they are learning in this discipline.
Yes, ma'am. I think both of you actually rightly said what an AI, machine learning, and data analytics, how it plays a vital role in chemical engineering, how it is integrated in our curriculum. So actually, I know I can ask a lot of questions about the scope and future, but a lot of our students who joined today actually want to understand, as a chemical engineering degree graduate or a chemical engineering student in Amrita, what they will be getting, what kind of things they will be learning. So most of them are keen about that. So let us move to the next segment where I'll give more insights about what exactly a chemical engineering graduate or chemical engineering student at Amrita, the resources he will get or what curriculum he will get. So my first question, ma'am, Meera ma'am, and just want to understand in terms of Amrita's this course perspective that we are offering, program perspective. What you can tell is the unique aspects of the chemical engineering program at Amrita University, how we are actually in the forefront or apart from other universities that offer this degree.
Okay. See, to equip our students with the knowledge and skills required to excel in the various roles that I mentioned earlier in different industries, our curriculum is designed to give our students a very strong foundation in science, mathematics, core engineering, and computing. So in core engineering, they learn basic, very relevant courses in chemical engineering like material and energy balance, thermodynamics, fluid mechanics, heat transfer, mass transfer, reaction engineering, process control, design, etc. Now, our curriculum and syllabus is being framed with a futuristic perspective, taking inputs from industry personnel, leading academic who are part of our board of studies, then alumni members who are working in both industry and academia. And many of our courses, if you see what is different from other universities, is that many of our courses are project based. And the core courses, including mathematics, have associated labs. Now we have a host of electives that the students can choose from depending on their interest and opportunities. We also have 2 specializations for those students who are interested. That is, as I mentioned earlier, process data analytics and AI. And the other specialization that we offer is environment and sustainability. However, if a student wants to they don't want to specialize in a particular area and they want to look at various options. That is also possible. They can have different electives. They can take 1 or 2 electives from process data analytics. They can take electives from the environment and sustainability. They can take electives in process intensification, safety, environment. So it is actually a very versatile program and quite flexible also. And another salient feature is that the industry internship is part of the curriculum. Every student has to undergo industry internship. And of course, there are, other than the projects associated with various subjects, students take up a course, take up a project in the 7th semester, which they continue in the 8th semester.
Yes, ma'am. I think I heard 3-4 important points that can make us stand out. First one is a more flexible, more versatile, and also more industry-oriented approach and industry-oriented curriculum. So that's rightly said. That is what is required today to make them a successful graduate in chemical engineering. But sir, as ma'am also told about industries, I just want to understand. I mean, from all our students also want to understand how does our university, Amrita University, integrate industry collaborations or real world applications into its chemical engineering curriculum?
Yeah, sure. Actually, as Meera Madam pointed out, we definitely we take the inputs from our all industrial collaborators. I would like to mention a few names here. One of our big industrial collaborator is Dow Chemicals. Next one is BPCL, Kochi especially, and IOCL, that is our that is close to Delhi, and LAM Research. So these are the names that I would like to mention a few, because we have a strong collaboration with them, with our research as well as from our academic front as well. So we will, before at this stage of the curriculum development, which will happen once in 4 years, means we revise our curriculum every 4 years. So at that time, we will take the inputs from our industrial collaborators. So especially if you look at the overall chemical engineering, there are 8 core chemical engineering courses. So we will get the inputs from these industrial collaborators about what are the latest developments around these 8 courses, or maybe in allied courses. So we take those inputs, and what are the softwares that is probably required to enhance our students' learning. So we will also would like to integrate them in our curriculum, so that they will also have a first-hand experience of the software that is used in the industries. So that's how we get help from our industrial collaborators. Now, if the second question that is related to this was, I think it is close to the real world application of chemical engineering, right? So I would like to give a brief one critical example here. No, in one of the critical calls named mass transfer, we learn a concept called steam distillation. So where we use steam to purify or extract some organic components. So nowadays, if you look at in all our real life, we use a lot of perfumes, all essential oils, something like we use rose oil, we use sandalwood oil or other things. So these sandalwood oil or the rose oil that we use in all our perfumes are actually produced from steam distillation. And I would like to mention one student batch which has developed a industry, not it's a commercial scale steam distillation unit to produce lemongrass distillation oil, which is primarily used in soaps and mosquito repellents. So and this lemongrass is not grown everywhere. So it is grown in a particular village in Kerala. So the students went and developed and applied their chemical engineering knowledge to develop a steam distillation unit to give the livelihood for the villagers there. So that's the critical real world example that I can name of.
Yes, sir.
I
That's
would
right.
also like to add that, this year, 30% of our final year students, our 8th semester students, they are currently in the industry.
Yeah,
they
doing
are
internship.
working on real, industrial problem, and that is their final year project. 30%, more than 30% actually, of our students are spending their 8th semester in the industry working on industry problems, and this internship will be converted into placement at the end of the project.
Yes, ma'am. That's very good to hear from both of you actually, because as a student, I need to understand whatever I am studying is actually really applicable or not. So they are getting it on in the final year, whatever they have learned in the past years, they're actually going out and implementing it and actually getting a job out of it is a very good thing to hear. And ma'am, when they sir also talked about steam distillation a thing which a student has developed. Likewise, I just want to ask one question, Meera ma'am, is there anything which you can highlight, any recent research or projects undertaken by our students or faculty in our chemical engineering department?
Yes, there are several projects. In fact, all our faculty, most of our faculty have projects funded by some funding agency, or some research organization like DRDO or ISRO, and of course DST is there. So we give opportunity for students who are interested in carrying out these kind of cutting edge research work. We give students opportunity to be part of that. Case in point is, currently I'm working on a project for Naval Research Board to develop a coating for Indian naval ships to absorb the noise. So two of my students, third year students, are working on that. Then some of our students have worked on taking an industry waste from rice mill industry. They burn a lot of husk, okay, and produce ash, which actually is a pollutant after the burn. So they have taken that and generated a nanoparticle, nanosilica into it, and that they have added into a rubber compound which is used in tire industry. So many opportunities are there. Uday's team was Dr. Uday's team was working on process intensification projects where they improve the efficiency of equipment to be in line with the sustainable development goals that we follow.
Yes, ma'am, that's very good to hear. Our chemical engineering students are changing the world because I see they are working in a lot of various domain, naval as well as decreasing the environmental impact. So that's very good to hear, ma'am. Actually, you see, very less students will get a chance to actually change the world. So I know, I think a lot of students who are attending this can understand this because leaving a mark with your work, with your research is what gives you more satisfaction in life. So, sir, Uday sir, just one thing I just want to make our students aware of how our university prepare its chemical engineering graduates for the evolving demands of the industry, because we currently live in a world where it is actually going to change in second, because we don't know what kind of technology will be there in the coming years, what kind of jobs will be there in the coming years. Actually, some people usually say like we are preparing ourselves for the jobs that are yet to be created. So how exactly our chemical engineering graduates, I mean chemical engineering graduates, are evolving with the demands of the industry?
Okay. So if you look at the primary definition what Meera madam has given about a chemical engineer is to convert a raw material into a more value added product. But sometimes the product purity is also very, very important. So right. So today the product purity may be some X, and tomorrow it may be 2X or something else. Right. So what is the current demand in the industry is the having the hands-on experience of the tools and equipments that they can be used to understand the purity of the component. This is ever required. This demand has to be met all the times. So the hands-on experience on the characterization equipment or analytical equipment is the demand. It will be there everywhere. And one more thing is that nowadays the chemical industries would like to suppose if you look at the stages of the chemical industry. So once they will do the process in a lab scale in a small vessel, and then they will go to a slightly higher level, which is a pilot scale, and then finally go to the commercial scale. So these are the general levels of the chemical process development. Now, so chemical industries would like to first, even before they do at the lab scale, first they want to understand whether this process can we how do we ensure this, this process will happen. So that's where your software tools will comes in handy. So therefore the state of the art simulation softwares are required. So Meera madam has mentioned a few, so I would like to mention a few more state of the art process simulation software, something like Aspen Plus, HDRI, and other things. Suppose today, so assume that I'm designing equipment. So how do I make sure that this design will definitely, so earlier they used to do a lot of trial and error. Nowadays, those trial and errors are minimized by using a simulation software. So those are the current demands that are existing for the.
Yes,
And
yes,
in Amrita, we do teach this state of the art that are actually used in industries. So as I mentioned, Aspen Plus and ISIS, we do teach students how that software will help them.
yes, sir, that's rightly said. I saw one of the question from the attendees also. I think Sundar Rajan. So he's asking about interdisciplinary areas. I think I'll ask you a question, Sundar Rajanji. Don't worry. I think I'll ask this question to Meera ma'am, since anyway a person asked about this. Ma'am, we just want to understand how does our university encourage interdisciplinary collaboration within the field of chemical engineering, both within the university or with the external departments or external programs or external partners. Because today we see a person who is a graduate should be jack of all trades, exactly saying, because you'll be working with a lot of engineers or a lot of other professionals and come up with a new product or new innovation. So how do you see this interdisciplinary collaboration can happen in the field of chemical engineering?
Okay. See, we promote interdisciplinary work within Amrita and with outside also. At the faculty level, if you see, we have, see, for example, I have research collaboration with civil engineering department. Okay, I am involved in water treatment projects there. I am collaborating with aerospace department for developing materials, high performance materials for launch vehicles. Then we are collaborating with mechanical department. I'm collaborating with the electrical department, like that. Okay. So now the question is, how do students get to collaborate with other departments? I just mentioned to you that two of my third year students are working on a project which we are doing for Naval Research Board. Okay? So they are involved in not only material development, they are also involved in simulation studies. Okay, how the flow affects the noise absorption characteristics, how the flow affects the drag, etc. Okay, so this they are carrying out in collaboration with the mechanical engineering department. Okay. So like this, the students, depending on their interest, get to collaborate with any department of their choice, because chemical engineering is a broad branch which is involved in almost every aspects of life. So depending on what the students' interests are, they can collaborate, undertake projects, and pursue their interests.
Yes, ma'am, that's rightly said. The interdisciplinary work is required and it's happening in our university at a bigger scale, because today, you see, as a university, we offer a lot of engineering programs and they have the freedom to collaborate with any student that is currently doing engineering in our university, not only first, second, third year. There is no actually a restriction in that part. They can actually come up with innovative ideas at any point of time when they are with us. So then One question, Uday sir, just want to ask is every student today actually having a dream. I want to study abroad. I want to go complete my MS, PhD abroad. So that used to be a dream for a lot of graduates today and all. How our university is helping them pursue higher education, and do we have any international collaborations that as a university, can you please share some
Yeah,
information?
sure. Actually, university at abroad, our Amrita Vishwavidyalaya at abroad, has a lot of MOUs with all the international university. Especially for chemical engineering, we have MOUs with Durham University, UK, and University of
KTH,
KTH, Sweden.
Sweden.
And we also have the KTH Zurich and Arizona State University, University of California, Santa Barbara. So all these are especially for chemical engineering, where they can do they can get, after they can do a 3+2 program. Means after studying 3 years, they can do 2 years. They can study in 2 years in these collaborating universities, where they can get MS directly. So obviously, no, the 2 years fees has to be taken care. That is one way of doing it. And the second way of doing it is basically a semester abroad program, where the final semester of the BTech program can where they have their project, so they can execute the project in the partner university partners at the international level.
Yes, sir. I can see. I think as a university, in a general perspective, I can tell we are collaborated with almost 200 plus foreign universities. And in terms of chemical engineering, also you heard the names that sir has said. We are collaborated with all top and Ivy League universities that we can name and mention in abroad. So, ma'am, before we end this script session, I'll just take few more minutes to ask two questions, because today every parent or a student concern is after joining a program, what kind of placement opportunities that are there for my kid or for me, and what kind of job roles actually I'll get. So if you can answer this, that will be helpful.
The job roles, as I said, are varied. Okay? So they can work as process engineer, they can work as design engineer, they can work in materials development. Depending on the sector that you choose, you can work in a lot of areas.
Yes, ma'am. Coming back to this, one more thing. I mean, what kind of companies usually come? Can you just tell us what kind of?
Probably I will say this with examples of where our students are working. Okay. See, Ms. Parvati CM from our first batch of chemical engineering, she is a lead engineer in Dow Chemicals. Okay. She joined Dow Chemicals after a very successful stint and another global company, where she won actually the Rising Star Award, which is an award given worldwide for rising chemical engineers. Okay. Then if you come to other sector people, our students are working in FL Smith. They are working in consultancies like Deolite. Okay. One of our alumnus is a faculty in IIT Gandhinagar. Okay. Our students, after writing GATE, because our syllabus is well equipped to prepare you for GATE exams, and the public sector companies take their graduate engineering trainees through GATE exam. So one of our many of our students are working there. One of them is Mr. PTR Gupta, who is a production manager at IOCL. Then if you look outside India, okay, our students are working in semiconductor industry. One of our student, Mr. Dr. Mugand Rao, okay, Mugand Rao, he completed his PhD and now he's working as an eco-climatologist and carbon cycle scientist. Another alumnus, Ms. Amrita Sri Menon, she is a global community lead for defense fabrication and controls in Rolls-Royce. So as I said, the areas are diverse and the opportunities are tremendous. Probably Dr. Uday will add some more names and
Yeah.
the roles that they play.
Yeah. I would like to add few more names. The first one is Aruna. She is currently the innovation scientist at DNV Technologies Australia. It is basically the DNV Technologies deal with the oil and gas transportation vessels. So how do we optimize the dynamics of the gas and oil and gas transportation vessels? So that is the role that she is taking part. And the other student is Maitreyi Uni. She is currently the R&D scientist at Core Quantum Technologies, which is dealing with the production of quantum dots for all our LCD displays and other things. And not only the LCD displays, it is also for all our dyeing, that means dyes that we produce for our clothes and other things. So that is the second name that comes to my mind. The third name is Anand Shankar, where he is the engineering head services for the process data analytics at Deloitte. So you can see, our students are placed in different industries in different roles.
Yes, sir. That's very actually a surprising thing, which I can see. Why? Because I never saw diverse domains a graduate can actually get placed. Because I heard a cosmetics industry, I heard a computing industry, I heard a automobile industry. So it's very good to hear. Actually, this is actually awareness for me also, more than students and also. Sir, just we'll take few more questions that were asked by students. I think we covered pretty much everything about the scope and about the things that chemical engineering can do in Amrita. But some of the students are asking some interesting questions. I'll just ask one question asked by, I think, Ravana Kumar. So my query is the forecast for fossil fuel availability will be for next 30 years maximum. In the view of this, how is the future of chemical engineering as a subject to study? I'm a parent and curious to know how is the institute geared up for such forthcoming challenges? Your views.
Right. So let me take up that question. I think the question, if I heard correctly, that is relevant to the extinction of the fossil fuels over the next 30 years. The question whoever asked, actually we are hearing this question since our BTech days. So we have completed our BTech probably 20 years ago or something like that. So, but still, no, we keep hearing that we lose fossil fuels within 30 days, so 30 years or probably 50 years. But that story is actually never ending. So, and please note, chemical engineers doesn't work only in the oil and gas industry, but they also work in other allied industries. And look at now, the clean hydrogen has picked up a lot, where chemical engineers are contributing a lot for the cleaner hydrogen production for water electrolysis. So you need not have any doubt about extinction of fossil fuels. They will be there, and they will be probably in other forms. So please note, whatever the technologies that were developed for the oil and gas industries, same technologies or similar technologies can also be used for the renewable resources, like conversion of biomass to the alternative fuels. For example, the one technology that we have developed is to convert the biomass to liquid fuels, which are actually engine grade, either petrol or diesel engine grade fuels. So it is actually from a renewable resource. The primary understanding of the oil and gas industry is what has actually helped to convert biomass to liquid fuels.
Yes, sir, that's rightly answered. Chemical engineering is not only about the work on fossil fuels, but there are other segments and sectors which you can work on also. Sir, one more question. I think any of you can take this up. One thing is they're asking, is there any specific program for green energy or hydrogen energy? Is there anything like that? Specific program?
No, currently, no. The clean energy production or cleaner hydrogen production is put into a separate elective stream called the process. environment
Sustainability and
sustainability, and also process simulation. So these selectives are in
process
both ways.
intensifications and
Yes.
electives are there.
Yes, so those will come in process intensification electives. We are offering a separate courses like the 3 credit course or 4 credit course, but not like a separate stream of electives, something like 6 or 7 courses together. No, we are not offering that way, but they are actually built up as part of the separate elective streams.
Yes, yes. I think Rahul asked. I think Rahul, I will answer this question. What is the average salary of a chemical engineer? The average salary of an Amrita graduate is 9 lakhs, Rahul. So I think it's one of the best in the country. And I'm a parent. What are the special electives in chemical engineering? I think so if anybody can answer, what are the special electives in chemical engineering?
Yeah, sure. Rather, we call it as a elective streams. Please note, these special elective streams is one what we mentioned is process data analytics and artificial intelligence. That is one stream of electives where there are 6 courses together to get that minor or the specialized elective. With they will get BTech chemical engineering degree with that specialization. The other special stream of electives is related to environment and sustainability, where we talk about the sustainability, life cycle assessment, cleaner energy production, and so on. That is third. And the fourth elective stream is process intensification.
Yes, sir. I think that's rightly said. I
For
think
those students who are interested, there are electives on renewable energy resources and systems, energy storage, green chemistry and engineering, electrochemical conversion and storage devices. So many are there. So it is what the students' interest is. And not only that, in Amrita, we do not restrain our students from taking electives that are relevant to only chemical engineering or the electives that we offer. You are free to choose electives from other branches of engineering as well, if that interests you.
okay.
So it is quite flexible.
Yes, ma'am. As rightly said in the starting of this webinar, actually, ma'am told it's one of the most flexible programs that Amrita has to offer. And before we have our end statements, all students, I am thinking all of you have applied for our university. If not, please do apply. I'm just launching one poll: how you want the seat allotment process to be? You want the seat allotment process to be done virtually, online, or physically? Please do answer this before we have the closing statements from both the faculty here. I think we have reached our time, and please do answer the poll that has launched. Do you want the counseling process, seat allotment process, to be offline, in campus, or online? Based on that, we will be taking the necessary steps. Please do complete this. I request all the applicants or all the attendees to answer this poll, because based on this, a decision will be taken by our university hierarchy. And please do answer this if you haven't answered as of now. And ma'am, I'll give you 1 minute time before we have a closing statement. Maybe in the meantime, you both can have a proper closing statement. It's a genuine doubt, ma'am, for every student or an aspiring engineer, why I should join chemical engineering other than the branches that are there. If you can tell me based on your experience and based on your expertise, both of you, that will be helpful for all our aspirants to make a wise decision in choosing this branch.
So, as I told, chemical engineers are in the forefront of addressing the most pressing issues that is faced by the world today. So if you want to contribute to development and sustainability, be a chemical engineer. Okay, you will be able to touch various aspects of life.
Thank you, ma'am. That's rightly said. Uday sir.
Yeah. See, I would like to answer one thing because see, please note this. I would like to take this statement from our COP26 commitment from India, wherein we would like to reduce our fossil fuel dependence, or we would like to cut out our CO2 emissions by 2070. We would like to cut off, and 40% of the current energy will be replaced by the cleaner energy. I think only chemical engineers can help India to move towards a sustainable and cleaner society. So
Yes, sir.
that's my statement on why you should join chemical engineering.
Yes, sir, that rightly said. I think all of you students, please understand, we are spiraling towards a place where a more cleaner and efficient energy is required, and also cleaner energy sources are required, and chemical engineers play a vital role in that. And there will be a demand in this sector and in this segment. Please make the decision wisely. Why I'm telling you this is, just understand. I'll give a small example. If Tesla, like company, I hope all of you know what is Tesla, who is the owner of it. If Tesla is coming to India and he is setting up factories, he is not going to bring all the workforce from America. He will hire people who are in our country who has that domain specific knowledge. It's as simple as that. If you have a domain specific knowledge in terms of chemical engineering, then you will have a right opportunity to work to provide a cleaner energy, a cleaner society, a cleaner environment. I think that will be my our take from this, and I hope all of you got right information today about chemical engineering, and all the required tools or required research opportunities, required feedbacks from the faculty we have received. Thank you, ma'am, Meera ma'am, and thank you, sir, for
Thank
giving
you.
your valuable time during your hectic schedule. And I
Thank you.
thank all the students who have patiently listened to us for 1 hour. And this video will be uploaded in YouTube. If any doubts related to admission process, please join us on every Friday in a virtual session. And I know there are a lot more questions, but there is a time limit to end. But don't worry, we will you can submit these questions to us over our btech@amrita.edu mail. We will be happy to answer your questions over a mail. Thank you, everyone. Have a good day. See you soon for the next Wednesday with Civil Engineering Department. Thank you. Thank you, sir.
Thank you.
Once again, thank you.
Thank you, and all the best for the participants.
Thank you.
All the participants, thank you very much for for your patience listening to us very quietly. So Sudhir, thank you for hosting us.
Thank you. Thank
I
you.
would also like to add, in case you want to know more about the branch, chemical engineering branch, and would like to interact with faculty, you are welcome to contact us and visit our department.
Sure, ma'am. We will invite our students to meet you. Thank you.